Hi, Jacob Wood here again with Music Teachnology tutorials. In this session we're going to be talking about microphones. There are a lot of different types of microphone, but here I'm going to be covering some of the more common ones to get you started. Dynamic microphones are very popular as they are robust and inexpensive. Dynamic microphones are also one of the most common and recognisable microphones available. They can be seen or used on recording drums and instruments as they offer recording to any loud sounds. Dynamic microphones work using the electromagnetic principle. The diaphragm vibrates when a sound wave hits the surface. This then moves the coil back and forth past magnets. This generates an electrical current that is sent down to the wires out of the microphone. An advantage of the dynamic microphone is that they don't require a power source. However, they are not suitable as computer microphones as they can pick up interference between different objects which will affect the sound quality. Dynamic microphones can be used for live recordings and studio recordings, therefore are quite versatile. Condenser microphones, like dynamic microphones, are very popular. The difference between the two, though, is the price. Condenser microphones, generally speaking, are a lot more expensive. The condenser microphone picks up a lot more detail than a dynamic microphone generally would do. Therefore, seem to be better for recording less aggressive or loud sounds, which a dynamic microphone may not necessarily pick up. Another thing to note with a condenser microphone is that they require some sort of power. This is normally what we call phantom power. Phantom power is a means of distributing an electrical current through the audio cable to provide power to the microphone. Condenser microphones work on the principle of capacitance. That is the ability to store a charge. They have two plates that have a voltage between them. One of the plates is a diaphragm. This is usually only a few microns thick and spattered with gold to make it electrically conductive. The second plate is called the backplate. This is fixed in position and usually has holes drilled into weight to allow air to move more freely. Condenser microphones generate signals when the diaphragm vibrates and moves closer and further away from the backplate. Fixed charge is placed across the two plates, so when they move closer, capacitance increases, and when they move away, capacitance decreases. This produces an electrical current that can be recorded. All condenser microphones, except electrics, need DC power in order to operate properly. While some high-end and vintage microphones draw power from an external dedicated power supply, most condenser microphones are designed to receive phantom power supplied by the preamble or mixing desk. Phantom power provides between 12 and 48 volts of power along the same XLR cable that carries the audio signal. If you plan on recording the condenser microphones, make sure to choose an interface that offers phantom power. Ribbon microphones have very similar properties to a condenser microphone, though they don't require phantom power. If you feed phantom power through a ribbon microphone, you will more than likely damage it. Ribbon microphones get their name from the way they have been constructed. A thin metal ribbon is suspended between two magnets. When the sound is made into the diaphragm of the microphone, the metal ribbon vibrates between the two magnets and is translated into an electrical signal. One of the things to add is that the ribbon microphone is very expensive. It can become damaged or distorted from something as simple as wind pressure or even slamming the lid shut on its case, so they need to be treated with extra care. Ribbon microphones will generally be good for recording subtle sounds such as acoustic guitar. It is suggested that the ribbon microphone only be used in the studio as it is quite fragile and can easily be damaged. An important characteristic of a microphone is its pickup pattern or polar pattern. These patterns are typically indicated by a standard name and a diagram that shows the sensitivity of the microphone to sound waves coming from various directions. Some microphones have a fixed pattern, some can switch between patterns, and some can change patterns only if the capsule is exchanged. In the standard polar pattern diagrams, the directional response is given in degrees, with 0 degrees the top of the diagram, representing sound coming directly at the mic's diaphragm, 180 degrees representing sound coming from the opposite direction. I'm now going to talk and guide you through some of the available polar patterns. A cardioid polar pattern is heart-shaped. This means that the sound is picked up mainly from the front of the microphone. Cardioid polar patterns on a microphone are recommended for focal applications, live tape recording, and most of the situations where the acoustics of the recording environment are good but not perfect. The hypercardioid polar pattern is a mushroom shape, making it slightly more directional than the cardioid microphone. Hypercardioid microphones work especially well for on-stage focal applications, helping to stop monitor feedback at live recordings when the acoustic environment is difficult. Omnidirectional polar patterns are open 360 degrees around the microphone. This means that any sound around the microphone will be picked up. Omnidirectional microphones are not suitable for live sound as they tend to be prone to feedback if amplified. They are, however, good for recording in the studio. The microphone with this type of polar pattern will be good for recording, say, a choir. Bidirectional polar patterns, also known as figure of 8, pick up sound from the front and rear of the microphone. It rejects sound from the sides as a cardioid pattern would, but picks up sound equally well from both the front and rear of the microphone. An example of bidirectional microphone is a ribbon mic. Ribbon microphones sound great on acoustic instruments in stereo configuration, for live recording of acoustics and jazz groups, and as drum overheads. They are also good for conducting face-to-face interviews. Shotgun polar patterns are named so because of the way they pick up sound. They are highly directional. Due to the narrowness of their sensitivity area, shotgun microphones are commonly used on television and film sets, in stadiums, and the field recording of wildlife. You will have seen film crews out on location with the fluffy little brush on a stick. This is an example of a shotgun microphone. The most common connections used by microphones are male XLR bastion connector on professional microphones, 1/4 inch, sometimes referred to as 6.3mm jack, also known as 1/4 inch TRS connector on less expensive consumer microphones, and 3.5mm, sometimes referred to as the 80s inch mini. Stereo, wired as mono, mini phono plug on very inexpensive and computer microphones. Some microphones use other connectors such as 5-pin XLR or mini XLR for connection to portable equipment. Some lavalier or lapel, from the days of attaching the microphone to the news reporter's suit lapel, microphones used a proprietary connector for connection to wireless transmitters.